Bismillahirrahmanirrahim. Hello, my dear students. How are you? I hope you are fine and enjoy good time and good health. Today, inshallah, we will resume talking about mathematics of finance with compound interest, rescheduling payments, or equations of value.
We will start with problem number 7. Given money is worth 6% compounded monthly and the focal date after 4 months from now, find the value of x. Timeline: the old obligations $50,000, the new obligations $20,000 and x. He will exchange one single payment with two payments. The focal date is after 4 years from now, and because of J equal 6% compounded monthly, M will be equal 12, and N for $50,000 equal 4, and for $20,000 equal 4, and for X will be equal 26 because of 2.5 years equal 30 months. 30 months subtract 4 equal 26. Substituting in formula I equal J over M, 6% over 12 equal 0.5%. Solution: J equal 6%, M equal 12, I equal 0.5%, M for 20,000 equal 4, M for 50,000 equal 4, and M for X equal 26. By substituting in formula of future value and formula of present value, you can get X, which is equal 55,747. The next problem number 8. Given money is worth 9% compounded quarterly, and the focal date is now, find the value of X. Look at the time diagram. He will exchange one single payment with two payments. One deserved now and the other after 3 years. To solve this problem by equations of value and by putting the focal date now, the main formula will be O1 equal N1 plus present value for X. So N for 50,000, 15,000 and 5,000 equals 0, and N for X will be equal 12. Why 12? Because the time between the maturity date for X and now equal 3 years, and the rate here, nominal rate 9% compounded quarterly. So 3 times 4 equal 12. To solve this problem, we must get I equal J over M, J 9%, M equal 4, so I equal 9% over 4. Solution, X will be equal 13,060. Problem number 9. Given money is worth 9.5% compounded annually, and the focal date is now. Find the value of X. Note that in time diagram, there is a positive value and a negative value. A positive time and a negative time. So 3 years previous now, there was $50,000. Now $25,000. He will exchange 2 old payments with 2 new payments. One reserve now equals $30,000 and the other reserve after 2 years. The main formula, depending on the position of focal date. The focal date here lies between the maturity values of old obligations and the new obligations. So sum of old obligations will get amount or future value, and the other will get present value. Also in new obligations. The main formula, O1 BO1 plus O2 equal N1 plus, again, amount or future value for $50,000 plus $25,000 equal $30,000 plus present value for X. Note that the nominal rate 9.5% compounded annually, so J equal 9.5% and I the same, and because of M equal 1 you can get M for obligations. M for $50,000 will be equal 3, and M for $25,000 and $30,000 equal 0, and M for X will be equal 2. Solution, X will be equal 72,716. Problem number 10. Given money is worth 8% compounded annually, find the value of X. by looking in timeline, you don't know the position of focal date, so you can put it at the time of X. So it will be after the maturity dates of old and new obligations, and the main formula will be the amount for O1 plus the amount of O2. By another way, the future value for O1 and the future value for O2 equal the future value for N1 plus N2. J equal 8% and compounded annually, so I will be equal 8%. M will be equal 1. M for $50,000 will be equal the time 3 plus 4 equals 7 years, so N equals 7. The time for $25,000 and $30,000 equal 4 years, so N equal 4, and N for X equal 0 because of the time equal 0. Note that the time here, it's a distance between the maturity date and focal date. Solution: because of J equal 8%, M equal 1, I equal J over M, so I equal 8%, N equal $30,000, أو M for $30,000 equal 4, $25,000 equal 4, M for $50,000 equal 7, and M for X equal 0. And by substituting in formula of future value and the present value, you can get X, which is equal $78,888. Another problem. Problem number 11. Payment of $18,000 and $25,000 were originally scheduled to be paid on 1 year and 5 years respectively. From now, the debtor asked the creditor to replace those payments by $12,000 payment due 4 years from today and the another payment due 2 years from now. The creditor has agreed to accept this settlement if money is worth 9% compounded semi-annually. What is the unknown payment? At the beginning, we must draw the timeline. Look at the timeline. The debtor owes with $18,000 after 1 year and $25,000 after 5 years. He will pay $12,000 after 4 years and X after 2 years. By looking at the problem, you don't know the position of focal date. So you can put it at the time of X. The main formula from the timeline, the future value for $18,000 plus present value for $25,000 equal x plus the present value for $12,000. To get n, you must know m. So, if money is worth 9% compounded semi-annually, J equal 9%, I equal J over M. Compounded semi-annually means M equal 2. So I equal 4.5%. Now you can get N. M for $18,000 equal 2 because of the time equal 1 year. M for X equal 0. M for $12,000 equal 4. And M for $25,000 equal 6. Look at the solution. J equal 9%, M equal 2, I equal 4.5%, N for X equal 0, M for $12,000 equal 4, M for $18,000 equal 2, at the end, M for $25,000 equal 6. By substituting in formula of future value and present value, the new obligations at left hand side and the old obligations at right hand side. X plus present value for $12,000 with a power of -4 equal the amount of $18,000 with N equal 2 plus the present value for $25,000 with a power of -n, which is equal -6. By substituting, you can get X, which is equal 28,791. This is the last example for now. See you next time, and thank you.